We now look at a very famous computational geometry problem, and this is known as line segment intersection. And this problem also admits a very interesting solution that is known as a sweep line. But before, let's just describe what this problem is about. You have an input of n line segments given to you, for example, by their two vertices. So maybe you have two coordinates that describe this point, another two coordinates that describe this one. And the output that we want is the intersection of all the line segments. So we want a huge, potentially a huge list. So the output of this algorithm might have some size k. If all the line segments are disjoint, none of them are intersecting, the output could be 0, or it could be constant, just a statement that there's no intersection. But potentially, if every pair of line segments intersects, then the output could have any squared size asymptotically. So in other words, before we solve this problem, we don't know how large the output is. As I said, the idea to solve this problem is to use a sweep line. I will basically mention what is the basic idea of sweep line, and then we're going to fill in the details. So the sweep line idea is something like this. Imagine a line, a horizontal line starting at plus infinity. And we slowly move this line downwards, and as soon as we hit one of the line segments, we kind of know that it's there. Just imagine that you're blindly trying to find what is inside in the plane, and you move the line down, and then you hit this endpoint, and you figure out that this line segment is part of the input. But so far, this is the only thing that you know exists. Then you go down a bit more, and you hit this other line segment. So now you know these two line segments are part of the input, and you figure out that this is their intersection point, so you output this. And you continue to do this until you find all of the line segments, or all of the intersections. Of course, this algorithm, as it is, cannot be implemented because there is no way we can continuously move a line segment or a line from positive infinity to negative infinity. So to be able to do this movement, we actually need to do it discretely. The basic idea here is that is to save computation. So let me put it this way: is to understand that there are event points. There are only discrete events in time for which we have to do something. To explain this, imagine that this. Let's go back here. So imagine that you just discovered these two line segments. Then as long as your sweep line is something looks like this, as long as your sweep line moving this much, nothing is happening in your picture. I mean, of course, the coordinate of the y coordinate of the sweep line is decreasing, but you're not discovering anything else, anything new. So the first time you discover something new is at this point. Okay, so you might as well just skip this continuous motion and immediately jump to this point in time. And that's the idea of the sweep line, that the picture changes only at discrete points in time. So therefore, we don't need to actually do the continuous movement. We can move discretely, and then we can actually code something. So that's the basic idea of the sweep line. And then I'm gonna talk about the event points of this algorithm in the next video.